So now there's one more thing that we need to do before we start assembling our phyloseq object. If we look at the contents of the tutorial COSIX directory, we see that the lost sample data table I sent you is still in this directory. We need to move that to phyloseq. So MV, the name of the file, and then the destination. And now if we look at the contents of the phyloseq directory, we see we have everything we need to assemble our phyloseq object: the representative sequences, the classification table, the sample data table we just moved into this directory, OTU table, and a rooted tree. So the next thing to do is to go to RStudio and start assembling our object. So here we are in RStudio. We have to go to that phyloseq folder. So the easiest way to do that is to first find it in the file manager. So here we are in Linux, Ubuntu, home, your ID, and then tutorial COSIX, phyloseq. So we can copy this, go back to our RStudio, click on this Files tab, and then these little dots here. Paste that into the folder here and open. So after we do that, we need to make this the working directory, and we can do that by clicking on this cogwheel and set as working directory. Okay, so now we're ready to assemble our phyloseq object. The first thing we need to do is to call the libraries we need to use. Library, phyloseq, library, biostrings, and library speedy tags. Okay, so select those lines and click Run. Now we're ready to start reading these files into R. First one I'll do is the OTU table, but since these are ASVs, I'll call it ASV. And the function is read table. You just have to give it the name of the file inside parentheses. So that's OTU table. Header equals true. The first line is the header line. Row names equals 1. The row names will be in the first column. And the separator here is TSV. So our tab delimited. And the way we enter that is a \T inside quotation marks. So if we go to execute that line, we see ASV appears in the global environment window. So we have 633 taxa and 10 variables. The rows are taxa, and the columns are different sample names. We will import the sample data table in the same way. I'll just call that SAM, read table, the name of the file, and that's read in. So now both of these, or if we look at the class for these, the class shows right down here, data frame. The same is true of SAM. It's also a data frame. To import these into phyloseq, we need to convert them to phyloseq objects. And we can do that like this. We'll just reassign ASV, OTU table, ASV, and then we need to say taxa or rows equals true. SAM, the sample data table, can be converted the same way. Sample data is the function in phyloseq. And that's all we need to do for that. So now if we look at the class for these, we see that it's an OTU table in phyloseq. So they've been converted. We can look at SAM the same way. So they're both phyloseq objects now. We can start importing the other things. Let's do the representative sequences. Call that repseqs. And so these are DNA sequences. We'll use the read DNA string set function from biostrings. We need to tell it the format. Which is faster. Now those are read in. We see them up here. So the tree file, I'll call my tree. And there's a function in phyloseq that's just read tree. Let's give it the name of the file. And the only other thing we need to do is to import the classification table. So I'll use a function from my SpeedyTax package for that. And I'm going to use this function here, import syntax tax table CPP. And to do that, I need to give it the file name first, which I can just do like this, and then the confidence. So for short reads like this, the confidence level recommended is 0.5. So now we have all the components. We can create our experiment level phyloseq object. I usually just call it expt. And the function is phyloseq. And just start listing the components. It doesn't matter what the order is, really. And we can list that. And we see we have all of these slots in the experiment level phyloseq object expt. All of those slots are filled. We have an OTU table, a sample data table, a taxonomy table, the phylogenetic tree, and the representative sequences. We want to save this. And the way to do that is to save RDS, name of the object, and then a file name. So I just give it the name expt and RDS to say what kind of file it is. So when we save that, we may have to refresh this. Now we see that that phyloseq object is saved to our phyloseq directory. And we're done. Now we can use that to analyze our data any way we want to in R.